Hello children. Today in this video we will learn time and motion lesson of class 7. So let's see, in previous prior knowledge we will see in the previous classes I have learned that measurement are expressed during standard unit. Physical quantities such as length, mass, time, capacity and temperature are measured using in different instruments. And rectilinear motion, circular motion and periodic motion are example of motion we see in everyday life. So the learning object of this chapter, in this chapter I will learn about the measurement of time, how time was measured in ancient times, pendulum clocks and quartz clock, speed and its unit, distance, time graphs. So let's see. So, look at the picture and discuss the following questions. All the participants in the race start running at the same time. Do they all run the same distance? How do we decide who is the winner in the race? You might have heard about how an athlete sets a record during a race. What does that mean? In previous classes, you have learned how length is measured. Let us now learn about the measurement of time and its importance in describing motion. Measurement of time. Measuring time is necessary in our daily life. In the absence of accurate time measurement, it will be difficult for us to do various things on right time, such as walking up, getting ready and reaching a school. We use clock and watches to keep track of time. Let us learn more about time and its measurement in this chapter. How time was measured in an ancient time. People in ancient time measured the passage of time by observing repeating natural event. For example, the period of time between one sunrise and the next was taken as one day. The period of time between one sunset and the following sunrise was considered one night. Thus, natural events such as sunrise and sunset, the phases of the moon, the change of seasons, and the migration of birds and animals were used to estimate time because they occurred regularly. Eventually, instruments that measured shorter time interval were invented. The study of these devices is called the horology. This is horology. Some of the instruments used for measuring time developed in ancient time are discussed below. Like a sundial. The sundial was used by people in ancient time to tell the time during the day. It consists of circular plate. You can see here sundial picture. It consists of a circular plates or dial with time divisions marked on it. A triangular structure called gnomon. So gnomon is fixed in the middle such that its shadow falls on the dial. When the sundial is placed in sunlight with the gnomon pointing in the north-south direction, the shadow that falls at the certain making indicates the time. Although sundial solved the problems of timekeeping during the daytime, but they could not be used during night and on cloudy days when there is no sunlight falling on the device. Next one is the water clock. You can see the picture of water clock. The water clock does not depend on the movement of the sun or other celestial bodies to indicate time. It could therefore be used even at night. It was invented by the ancient Greek in a water clock. Time is measured by observing the regulated flow of water into or out of a vessel. The bowl that receives the water has marking to indicate time interval. Figure 12.2 you can see. The drawback of water clocks was that they required regular monitoring as the rate of flow of water varies with temperature. Next one is sand clock. You can see this sand clock. The sand clock, also known as the hourglass, was used to measure a small interval of time such as minutes. It consists of two bulbs joining together vertically with a certain amount of sand filled in one bulb. The sand is allowed to flow in a regulated manner from the bulb into the other through a small opening until the top bulb empties. This regulated flow of sand is used to measure minutes and sometimes hours. In modern times, hourglasses are sometimes used to measure small interval of time or may be used as decorative item. Now we will see modern instrument used to measure time. Modern instruments used to measure time are far more accurate than earlier devices. A major step in earlier development was the invention of pendulum clock. You can see here the mean position of simple pendulum, and this is the called bob. Pendulum clock. A pendulum clock is based on the motion of a pendulum. A simple pendulum consists of a weight called bob. You can see this is the bob hanging from a string. The position of the bob when it is at rest is said to be mean position. If we move the bob away from its mean position, displace the bob and let go of it, the bob moves in to and fro motion. One complete to and fro movement of a pendulum is called the oscillation. The time taken by a pendulum to make one complete oscillation is known as the time period. So you can see to and fro motion of a pendulum. The motion that repeats itself after regular interval of time is called periodic motion. The oscillatory motion of a pendulum is also an example of periodic motion, as oscillations in a pendulum repeat after a fixed time interval. It is observed that the time period of a pendulum depends only on the length of the pendulum and not on the displacement and the weight of the bob. Therefore, a pendulum of the given length always takes the same time to complete one oscillation. This observation led to the development of the pendulum clock. You can see here the picture of pendulum clock. In a pendulum clock, the periodic motion of the pendulum is used to move the hands of the clock that indicate time. Wound spring unwind very slowly to make the pendulum swing continuously. This is the activity to verify that the time period of a pendulum remains constant. So you can see this activity and read it. Quartz clock. With the invention of quartz crystals in 1927, pendulum clocks were replaced with quartz clock. Quartz crystal vibrate when placed under an electric field by suitable mean. These vibrations are converted to measure time. Quartz clock measure time with high accuracy comparison to pendulum clock. And you can see here real world and tech updates. Atomic clocks keep time by observing certain vibration within atoms, usually in caesium and niobium, that are exposed to specific conditions. These clocks only have an error of 1 second in a span of about her hundreds million years. This makes them the most accurate timekeeping device in India. So IST, Indian Standard Time, is maintained by the CSIR Natural Physical Laboratory using a bank of the caesium atomic clock. And tech update, during races, the other sporting event, it is very important to accurate measuring the time at which an athlete leave the starting block of the crossing the finishing line. The electronic starter used to signal the start of the race is linked to a flashing light and an audio system in each starting block. Starting blocks and finishing line also have sensors that record the exact time at which an athlete leave the starting block or reach the finishing line. Special cameras and sensors placed at specific angles at the finishing line capture image to determine which athlete crosses the finishing line first. Now, unit of time. Units of time. The SI units of time is second and its symbol is S. Other unit of time can be used to measure long or short period of time. So you can see the units of time in the period, units and conversion. Here millisecond, 1 millisecond is equal to 1 upon 1000 seconds. So and so on. You can see this chart. So knowledge checking, state whether the following statements are true or false. Correct and false statement. You see the statement and give the answer. Now we will discuss about the speed. What is speed? Two cars in a race leave from the same starting point at the same time but reach the finishing line at different time. The car that covers the distance in the least amount of time was the race. This is because it was moving faster than the other. How do we decide which car was moving faster and which was slower? We can compare the distance covered by each car in the same interval of time or time taken for covering a fixed distance. So, speed is the distance covered by a moving object in a unit interval of time. Speed is calculated as the distance traveled per unit time. Therefore, speed is equal to distance upon time. So this is the formula of speed calculation. Speed is equal to distance covered by unit time. A unit of speed. The SI unit of speed is measured by second, meter per second. However, in everyday practice, speed is measured in kilometer per hour. Conversion of unit of speed. So you can see here conversion to convert kilometer per hour into meter per second and convert meter per second into kilometer per hour. So 1 kilometer is equal to 1000 meter and 1 hour is equal to 3600 seconds. So 1 meter is equal to 1 upon 1000 kilometer and 1 second may 1 upon 3600 hours. So you can convert the units. Multiplying the value in kilometer per hour, you can see this, and solve problem. Numerical, you can see here the numerical. An athlete cover a distance of 100 meter in 20 seconds. Calculate their speed in kilometer per hour. So we know that 1 meter is equal to 1 upon 1000 kilometer and 1 second is equal to 1 upon 3600 per hour. So also speed is equal to total distance travel per total time taken. This is the formula. So speed of athlete is equal to 100 upon 20 seconds. This is given in the question, 100 meter per in 20 seconds. So 100 upon 20 into 36 upon 1000. So here the unit one we can write 1 upon 1000 upon 1 upon 3600. So it's a reversible. So we just inverse of 3 opposites units. Kilometer per hour में we can find after cutting 18 kilometer per hour. Now there is a second problem. An aeroplane flies at an average speed 800 km per hour. It flies from the New Delhi to Kolkata, covering a distance of 1400 km. So here speed is given and distance is given. How much time will the aeroplane take to complete it? So now we have to find the time. So we know that speed is equal to total distance travel divided by total time taken. So speed of aeroplane 800 km per hour. So we can put here speed. So you can see here we put the value of speed putting here and time, total time taken we need to find. So total distance travel upon speed, yani 1400 km per hour distance travel and speed is 800. So time taken we can find 1.75 per hour. So in this way we can find the time taken. Same thing if we have to find the distance traveled. So we can multiply time taken and speed both. So using the formula of speed, you can find any unit of. Now measuring speed. So you can see here speedometer and odometer. Vehicles such as cars, trucks and motorcycle have a device called speedometer that display the speed of the vehicle in kilometers per hour. The speedometer measures the speed of vehicle at the specific moment, that is a instantaneous speed. Vehicle is also have an odometer. Speedometer measures the speed of vehicle and odometer that displays the distance traveled by the vehicle in kilometer. Measuring speed, you can see here speedometer can measure the speed and odometer that display the distance traveled by the vehicle in kilometer. It is often displayed in the sum console in speedometer. You can see here in the picture speedometer and odometer. Now, uniform speed and non-uniform speed. So you can see here, when an object covers equal distance in equal interval, it is said to be moving a uniform speed or constant speed. This type of motion is called uniform motion. If an object covers unequal distance in equal time interval or equal distance in unequal time interval, it is said to be moving in non-uniform speed. This type of motion is called the non-uniform motion. When an object is moving at non-uniform speed, the speed we calculate it is average speed. Generally, vehicles do not move with the constant speed on the road. They keep on changing their speed throughout their motion. Thus, the motion of vehicle on the road is the non-uniform motion, not on vehicle in daily life. It is rare to find any object that moves with a constant speed. So we calculate the average speed of the moving object. So the formula of average speed: total distance traveled, total time taken. Now measuring distance time graph. This is the important thing. Distance time graph. The graphical representation in which information is presented with the line is called line graph. A line graph that represents the motion of the moving object is called distance time graph. In a distance time graph, time is plotted along a horizontal line x-axis and the distance covered by the moving object is plotted along a vertical line called y-axis. The point where x-axis and y-axis intersect each other is called origin. Let us learn to plot a distance time graph. Let us consider a moving car with a uniform speed, the distance covered by the car and the time taken as shown in the given table. So you can see this is time and this is distance. 0 time पे 0 distance and 1 minute में 2 kilometer, 2 hours में 2 4, 3 में 6 4. This information can be plotted in a line graph in the following steps. Take a graph paper and draw into two lines perpendicular to each other. On it, make a horizontal line x-axis and the vertical line as y-axis. Mark the point of their intersection of origin O. You can see in the graph. This is the time per minute and distance per kilometer. So we can distance time graph we can plot like this according the table. So in time, in 1 minute में 2 kilometer covered and 2 minutes में 4 kilometer covered, 3 minutes में 6 kilometer, 4 hour में 8 kilometers. So this is the now we can just crossing the point, we can just plot a line, straight line. This shows the uniform motion. So mark the point on the graph to represent each set of value for time and distance. Join all points with a line as shown in the figure. It is a straight line. This is the type of motion of a moving object can be predicted by looking at the following distance time graph. If the distance time graph is horizontal line parallel to x-axis, it indicates a stationary object. If the distance time graph is a straight line passing through the origin, then the motion of the object is uniform. This is the stationary object. You can see here a horizontal line. An object moving with uniform speed. That means according the time, distance increases in same amount. Time and distance graph, object moving with non-uniform. You can see in this graph. So if the distance time graph is a curve, then the motion of the object is non-uniform. The object keeps on changing its speed, that is, it travels unequal distance in regular interval of time or vice versa. So this is the very important different distance time graph. You can see here, this is stationary, this is the uniform speed and non-uniform speed of motion. Here time and motion concept map you can see. And now some important keywords you need to learn. Periodic motion or oscillatory motion, a motion in which to and fro movement are repeated at regular interval of time. Time period, speed, uniform motion, non-uniform motion. You need to learn these keywords. And this is the summary of the chapter. Here are some practice questions. Fill in the blanks. You can see and try to attempt. Question number B. Fill in the blanks using the helping words. Match the following. You can do it. And after the chapter, answer the following questions. Numerical problem also are given. You need to attempt it. Some skill enrichment.